Hi, I'm John Lennon, and I love impressive science. Here's the question of the day. Why did you Americans go helter-skelter over that whole polar vortex thing? Afraid your eyeballs might freeze over? Well, here at Impressive Science, we're excited to tell you a few of the reasons, scientifically speaking, why the polar vortex was quite dangerous. You see, salt water, or brine, freezes when the temperature goes down below 0 degrees Fahrenheit. You know brine? The stuff you might find under the sea, in an octopus's garden in the shade? Maybe outside of your yellow submarine, eh? Normally, water molecules are pretty rock and roll. Water is a polar molecule, so it has a positive end up by the H's and a negative end down by the O darlings. Now, water molecules are quite attracted to one another, and they like to stick together, forming weak hydrogen bonds. At room temperature, these water molecules are really energetic, so they can't hold on to their neighbours with their hydrogen bonds very easily, so they just move fluidly past one another. We call that a liquid. But as you cool the temperature, they slow down and lose their energy.
I'm so tired, I haven't slept awake. I'm so tired.
Below 32 degrees Fahrenheit, the water molecules are so tired that they come together. This is what we call ice. They are hydrogen bonded. These water molecules are crystallized, solid, bonded, just like us Beatles were back, at least in the early 60s.
Unless you add salt. Na 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 na, and some chlorine ions as well. You see, salt, sodium chloride, dissolves in water, pushing the water molecules apart, making it harder to freeze and form ice. It's sort of like Yoko Ono, breaking up the bond.
Technically, it's due to the electrostatic screening of the intermolecular hydrogen bonds, but you get what I'm talking about. Shut up, I'm John Lennon!
Long story short, salt lowers the freezing temperature of water. See, this is why you put salt on your Abbey Road. It stops it from icing over.
Why don't we just bond it in the road? No! No, 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 no!
But what if it keeps getting colder? What if the temperature drops below 32 degrees Fahrenheit? Way below.
So cold that helter-skelter freezes over.
At 0 degrees Fahrenheit, even salt water freezes.
I'm Daniel Fahrenheit, and I use the freezing point of salt water to set the 0 point of my temperature scale.
You see that silly little polar vortex? Made the roads colder than normal rock salt can melt, turning driving into a terrifying nightmare. Looks like the bond's getting back together, eh? So there it is. Now you understand why the long and winding road is so dangerous when the temperature drops below 0 degrees Fahrenheit. Next week on Impressive Science, I'm going to tell you why it's scientifically impossible for Ringo Starr to keep a steady beat, eh?